So you are in the main room for green. Just remember, each of the various talks also have overflow rooms. So if the main room is full or you feel like you don't want to sit near people, please feel free to use some of the other rooms. Additionally, we will be taking questions in the green Slack channel. So if you have a question, please put it in there. Also, if you would please, visit the sponsors. Without the sponsors, we couldn't make this happen. So without further ado, I'd like to introduce Craig Stuntz, your speaker for this morning.
So I'm going to kick off the talk at 8:30 sharp. That's about 1 minute from now. So hang tight, and we'll get started on time. Everybody still here well in the back? Awesome. Okay. Okay, everybody wide awake this morning? I'll tell you, it's quite a different experience to have the light in my face here at 8:30 in the morning. My slides are already online. You can pull them down at speakerdeck.com/CraigStuntz. I do reference some other links for further information deeper in the slideshow, so this is a good entry point if you want to look up any of the material I talk about later on. As you may know, we're actually talking to 3 theaters this morning, so we're going to be taking the questions via Slack. I have a full hour of material, so there's not going to be like 10 minutes of dead air at the end for questions. So if you have a question that you think is of general interest to the entire audience, put it on the Slack channel, and Matt's going to interrupt me during the talk if he sees an especially good question come through on Slack. So please do feel free to ask there. And if you have a question that's maybe not of general interest to the whole audience, maybe something specific to you, I also put my Slack username up there. You can send me a DM and we can talk in private if you'd like to ask something that, that maybe you don't think the entire Stir Trek is going to want to hear about. So the genesis of this talk was I had a client who's had a contract with one of their clients that required their developers to take OWASP training. So they asked me to provide this to their developers. And of course, the first thing I said is, what exactly is OWASP training? And they said, well, we're not exactly sure, but we're required to check this box for the contract, so we'd like you to put something together. And I believe they meant the OWASP Top 10. But my take on the OWASP Top 10 is it's full of good ideas, but it's not really sufficient if you follow all the guidelines in the OWASP Top 10. It doesn't get you to where you need to go to actually write a secure application. I've done a lot of security talks over the past few years, but they've always been in sort of highly specific areas, things like homomorphic encryption and fuzzing. I had never really had the opportunity to put together my sort of general broad view on what does it mean to develop a secure application and what exactly is the application lifecycle, what is that process. So it was a good time for me to sort of step back and reflect and say, how can we build security into an application development lifecycle, and what exactly does that look like when our feet hit the ground? So I'm going to lean very heavily on a document from the Indiana University's Center for Applied Cybersecurity Research called the Information Security Practice Principles, and I'll dig into that later on in the show. So let's start at the beginning. Let's talk about how do you get started in programming? Well, how do you get started in the medical profession? What you see here on the screen is an extract from a modern version of one of the oldest binding documents in human history. Many doctors start their careers with a Hippocratic Oath. And how do you get started in construction? Safety first. Safety is our top priority. Let's contrast this. How do you get started in software? I'll tell you, I like the other ones better. I think that the other ones are a lot more thoughtful. So here's a remarkable fact. Exactly 0 passengers were killed in air transportation in 2017. However, and the interesting little blivet buried at the end of this story, experts caution that it's unlikely we can maintain this low level of passenger deaths because many passengers are carrying laptops and the batteries might explode. So imagine saying to someone in 1968 that the biggest risk to 2018 air transportation might be the computing industry's disregard for human safety. So here's a question. Would you approach software design differently if we worked like the medical and the construction industries? If human safety were always the first consideration that we made when we started our careers and when we started a project? And what exactly would that even look like? This is not an original idea to me. The very first principle on which the Association for Computing Machinery's proposed updated code of ethics is based on the idea of protecting people, protecting human rights, and avoiding harm. It's easy to look at like phishing statistics, and this is something I hear a lot from developers and security practitioners, to say that we could build secure systems if only it weren't for those darn humans. But really, humans are the target. Humans are not the problem. Humans are the reason that systems are attacked. I think that computing today is in a place kind of similar to where we were at the start of the Industrial Revolution. We're enjoying this new productivity. We love that, but we're starting to notice, the smog and the factory accidents. So let's step back and say, what does it mean? What does security even mean to begin with? We use the word security to mean different things. So let's ask, what does it mean in the context of software? One way I like to think about security is it's a form of domain-specific QA. I think that security analysts and QA professionals actually have a lot in common. Now, developers, QAs, and security analysts are all concerned about the actual behavior of software. Some of this is going to be described by a specification that might be a formal specification or more commonly an informal specification. QAs are going to investigate whether the behavior correctly conforms to the specification or whether it fails. And a good QA is also going to expand the specification as they work. Security analysts, on the other hand, are really most interested in the areas where the behavior of the application falls outside of the specification, but also areas where the specification might be self-contradictory. So to recap a little bit, QAs ask, does the software do what it should? A security professional might say, does it also do anything else? And I think all of us need to think about, do we even know what the software is supposed to do? Here's one more thing that QA and security have in common, is that they're not just something you can shake onto a crappy app at the end of a development process and just magically make everything better, right? QAs and security professionals will want to help you with the design of your application early on in the application development lifecycle to push potential problems earlier in the development process where they're easier to take care of. And sometimes you hear people call this pushing application security left. Pushing application security left. So that sounds like a good idea, but what does it actually mean in terms of a development lifecycle? I went looking for prior art about what it means to have a security team involved with the application development process, And actually, there's not a lot of research and published processes for this. One that I did find is a NIST standard from 2008 called NIST 864. It describes 5 phases of an application's lifetime. The first is initiation of the use of the application. The second is development or acquisition of software. The third is implementation and assessment. The fourth is operations and maintenance. And the fifth is disposal. The diagram on the screen here is their description of the second phase, which is development and acquisition. And funny, it's a little hard to read because it's a pretty dense slide, but one of the things that's really missing from their phase 2 is actual development. They don't really go into very deeply what it means to have a secure development process. It's still quite separate here. The OWASP organization, the Online Web Application Security Project, has a draft secure development lifecycle, which, it sounds promising. It's not really ready for prime time right now, but if this is an area that you're interested in, it's an open source project, I'm sure they'd appreciate your contributions. Microsoft has a secure development lifecycle, which is probably the best of all that I've seen so far in terms of something that's usable today, but it's still pretty thin. So one thing it has that's super useful is the Microsoft SDLC comes with some tools, one of which you'll see quite a bit of later on in the deck called the Threat Modeling Toolkit. They also come with Attack Surface Analyzer and Code Analysis. But with the exception of threat modeling on this screen, which you absolutely should do, the emphasis on this slide is really technical and process control. And that's important, but I also think that domain knowledge and application design to be usable by human beings is just as important, if not more so, in terms of building a secure application. I'll get into what that means a little bit more. I'm just saying I find this model to be maybe not quite the be-all and the end-all of what we would want for a secure development lifecycle. The designers of the Microsoft SDLC are adamant that it does work in an agile process, but it's not exactly spelled out. And I find application design questions to be sort of understated, if not ignored altogether in the Microsoft SDLC. But we can pretty easily lay an interactive process of design improvement over a standard agile process. The processes are quite compatible. Now, I've just dropped a bunch of words on the screen that I haven't really explained yet. So I'm going to be talking about 7 fundamental principles of information security. But first, I want to define some terms. And the first thing I want to do is just talk about what secure applications even mean. If you're coming from the security community, this is going to be old news to you. But this is a developer conference, so I want to sort of step back and talk about what it means to build a secure application. And I'm doing this by first covering some myths of application security, and then we'll talk about some truth. So a bank is going to harm their customers just as much if they lay your deposits out on the street, just as much as if they get held up. It's not always good guys versus bad guys. You're just as likely to harm end-user security via incompetence or errors as via a direct attack. There's this notion, and I hear this repeated as gospel, that you have to choose between inconvenience to the end user and good security. And the funny thing about that is it's just not true. If your security is inconvenient, users will route around it. So this idea, I wanted to make sure this wasn't a straw man. And so I went looking for someone actually making this claim. And I got a little nervous because Bruce Schneier knows more about security than probably I ever will. But I want to sort of gently push back on this idea. This is repeated often as a truism. On the internet, attack is easier than defense. It's not exactly wrong, but it's also not so correct as to deserve a moniker, a truism. A complex system can often have a large attack surface, but real-world exploits of good secure applications like Chrome, they rarely depend on a single vulnerability. this notion that if you make even a single mistake, your site's going to get owned is, it's just not true. And I think it leads to a form of nihilism. Like, why should we bother having a secure development process if a single mistake is going to end everything? As far as we know, most sites don't get popped. This notion, like I said, it's really common to find this written into software development contracts. The OWASP Top 10 is a useful document. It's essentially a collection of mistakes that you might make and shouldn't make. And so it's useful to go through this checklist and make sure you're covered in that respects. But the problem I have with it is that even if you don't make a single mistake that's in the OWASP Top 10, it doesn't mean you have a secure application. There are things like human factors that are really just not covered at all. OWASP has another document called the Proactive Top 10, which I think is a little bit better. But I really want to say, what is a view of a secure application process that is more comprehensive? Your social networking startup might be 100% public, but it won't stop governments from weaponizing it. Your end users are still people, so they're still targets, even if it's just all public information. And this notion here is even more dangerous because there's no item on this list that's a bad idea, but this list can go on forever. And so again, I feel like this leads to a form of security nihilism where you say, we can't possibly cover all of our bases. You know, we'll do a couple things, we'll check that box and be done. We don't really ask the question, what does it mean to have a beginning to end secure application? And that's what I'm looking for. So here are some truths. Security decisions that are made without the context of an articulated threat model, and I will spell out what a threat model means if it's a new concept, are speculation and folklore. I'm going to elaborate on this going forward. You can't describe a system as secure or insecure, and you can't just wave the word security around to justify a decision. Every bad password policy follows from the mistake described on the quote here. The NSA released a report earlier this year that said in 2017, they were not aware of any advanced persistent threat attacks that were done using zero-day vulnerabilities. It was all off-the-shelf, unpatched vulnerabilities that are just the result of people not keeping their stuff up to date. Fortunately, however, there is a solution. You could say there's a magic bullet that can take care of all of this. So we can turn to the Reverend Dr. Fred Rogers for advice on how to move forward. This is a little vague, so let's dig into it specifically. We don't want to blindly pull every mitigation imaginable into our process. We want to assemble a suite of components which build our design. We're going to start by a human-centered design, thinking about the risk to the end users of our product and our community. But what does that mean exactly? I keep saying, come back to human safety. What exactly does that mean? In most domains, there are non-obvious risks to human safety, as well as areas in which traditional security rules fall flat on their face. So one of the rules that you hear repeated a lot is don't open email attachments. It's a bad idea to open email attachments from strangers. I kind of agree with that, but here's the rub. In nearly every company, you have someone or a team of people, usually in HR, whose essential job it is to open Word documents and PDFs from emails from strangers, anonymous idiots on the internet. You can't tell these folks to don't do your job. You're a bad person if you open an email attachment. It's essential to their core function to the company. So instead of telling people the problem is your behavior, we need to give them tools in order to do their job in a secure way. Like maybe they need to read their email on an iPad or something. So let's consider some fails. Is a spell checker security-sensitive software? It is if it automatically and silently changes your prescription. Amazon continued to sell unsafe Eclipse glasses for a couple of weeks last year. Facebook, we're told, is designed to bring people together, but groups who wanted to interfere in US politics used it to try and start a fight. iTunes wasn't designed as a money laundering system. It's designed to be a terrible music player, but where money is involved, people will find a way. You know, you may not think of your refrigerator as a security-sensitive device, but IoT devices are regularly weaponized because they don't tend to be patched. So can we do better? I mean, I've shown you a bunch of ways that security can go wrong. I want to think about what does it mean to go right? So one of the things that we can't do is just rely on having smart team members, because we all have bad days. We all make mistakes. You know, y'all are here at Star Trek hoping to learn about secure development, and that's great, and I applaud you for coming. But, you know, we know there are a lot of developers who are not in this workshop. So can we put a process in place so that we're not just relying on people being at 100% in order to have a good, secure development lifecycle? So in order to make good security decisions, we need an accurate threat model. And a threat model is a plan that addresses three essential questions. Who is affected by your software? What do you have? And what could go wrong? So I'm going to expand on all three of these. Who is affected by your software? Actually, it's not just your end users. It affects a lot of people. So ask yourself, who are your users? Who are your customers? Users and customers are often not the same thing. Who are the people who are on your team? Stakeholders in your organization, partners of your company, and who are the community? A lot of people who do threat modeling for a living don't really go beyond the end user, and I think we have to take an expansive version of this, and we're just going to list these out. Next question is, what are you building? This includes a lot of things. It's not just software. It includes the infrastructure that runs your site, the data you collect, not only just databases, but also things like cookies on the end user machine. We need to think about the trust boundaries in your software. This can be explicit trust boundaries like network partitions, but also implicit trust boundaries like escalation of privilege. And then we want to take these lists and turn them into a comprehensive list of what could go wrong. Who might attack it? What else could go wrong? This includes known attack vectors against specific parts of your infrastructure, but also much more. And for each one of these things that could go wrong, we need to decide what is the severity of it and what is our response to this. We could accept the risk, we could fix the risk, or we could mitigate it with like, some kind of monitoring. So it's not just a list of infrastructure and things that are known to go wrong with that bit of infrastructure. It's important that we start with domain-specific risks. As I said, we want to think about human safety first. And in order to do that, we have to learn from history. We need to talk to business analysts or red team members about past experiences in the organization. And we need to think about existential threats. So this is something that may not sound like a security bug, but it wiped out an entire organization. I would put that in the security category. In 2012, a software bug caused Knight Capital's high-speed trading system to issue millions of bad trades over 45 minutes. It cost the company $440 million and ended their business. Also, in many industries, and like this includes you, if you have a single European user right now, there are regulatory concerns. So the GDPR is landing this year. You probably got updated terms of service from every site in the world right now. But it has interesting impacts on application architecture. So if you have an event-sourced architecture, you need to consider, we think of event sourcing as this immutable stream of events, but the right to be forgotten is something that you need to be supporting if you have a single European user. And if you're thinking of your event sourcing as an immutable stream of events, you also need to think, what does it mean to go back and remove an end user's data from that so-called immutable stream? Okay, so hopefully it's a little bit clearer what a threat model is. We're going to make these collections of users, of things that we have, and of what could go wrong. It's a step forward to have a prioritized list of risks, but how do you turn these lists of people, things, and risks into a real threat model, and how can you use that as part of your secure application development lifecycle? So I went looking for prior art on this question. One of the interesting things about software is we probably would not be writing a software project if what we were building was available off the shelf. I mean, hopefully not, right? Hopefully we're not just reinventing the wheel every time we go to work. But there's an interesting implication of that, which says that for a specific domain, every time I start a new project, there's not really best practices for the thing I'm building. So what I wanted to look at is to say, is there prior art on how to build a list of best practices in a new domain? The Information Security Practice Principles from the Indiana University Center for Applied Cybersecurity Research is designed to help secure technologies and systems where best practices haven't emerged. And so if you're using next week's JavaScript framework, it's a good time to look into these principles and say, what does it mean to secure this new tool? There are 7 principles. I'm going to just briefly describe each one, and then we're going to work through an example of how you might apply those 7 principles in a sample software development project. So the first principle is comprehensivity. The principle, and some of these words are a little bit of a mouthful, but the principle is simple enough. We want to identify and account for all relevant systems, actors, that means people, and risks in the environment. The second is opportunity. We want to take advantage of actor relationships, material resources, strategic opportunities that are available in the environment. The third is rigor. We want to specify and enforce the inspected states, behaviors, and processes governing the relevant systems and actors. Rigor has two phases, specification and enforcement. The fourth, minimization. Minimize the size, quantity, and complexity of what is to be protected and limit externally facing points of attack. We want to minimize time as well. We want to delete data, remove unused code from the application. Fifth is compartmentalization. Totally isolate system elements that enable and control the interactions between those system elements that are essential for their intended purpose. We often think of this in terms of network partitioning, but network partitioning is leaky, so you don't want to think about like inside my network is secure and outside my network is the Wild West, because people will phish users inside your network. Instead, this is more about preventing lateral movement. We can compartmentalize on identity or elevation of privilege. The sixth principle is fault tolerance. Anticipate and address the potential compromise and failure of system elements and security controls. And the last principle is proportionality. We want to tailor security strategies to the degree of risk, accounting for practical constraints imposed by the use case and the environment. So there is quite a bit of research behind these 7 principles. We have reasons to believe that they're broadly applicable, but having just described these principles, I mean, hopefully it's obvious what they mean, but I'm asserting to you that if you follow the principles, you can have a secure process. It may not be obvious what that means, so I would like to work through a practical example to maybe make it a little clearer about how to use these principles in a real-world software project. And especially I want to think, how can you decide when you're done? This is a challenge in security design. So this is a real project that I worked on for a client. The business problem is there's a hotel chain, and they need to capture credit card data for potential incidental charges on a room in cases where the cardholder will not be present at check-in. So an example of this is there might be a high school sports team that has reserved a block of rooms. The students will be staying, in the hotel with chaperones. The parents want to provide their credit card number to the hotel for incidentals. Hopefully the students are on their best behavior there. And the current process that the hotel has for this is a paper form. You download the form from their site, you fill in your credit card number in the CVV2, you fax it to the hotel, the general manager pulls the document out of the fax machine and puts it hopefully in a secure place. They realize that this current process is maybe not the best, So they'd like to automate it and maybe provide better controls over what happens with that CVV2 number. So where do you even begin on a problem like this? I mean, again, you're all smart people. You may have ideas about how to do this securely. But what I would like to do here is start with a very naive solution, because I want to say, I really want a process that doesn't depend on having geniuses and people who have a lot of experience with security on your team. I'd like security to come with the process more so than the training. So let's start with a naive solution. And there's no problem actually with doing that as long as you don't end with the naive solution. So in the naive solution, the cardholder accesses a web application and stores their credit card and their CVV2 in a SQL database. The hotel manager is going to use the same web application to retrieve that information from the SQL database. This would kind of work, but we care about security, so we're using HTTPS. I think we need to do a little better than that. So is there a method that we can use that will allow that will allow developers, even without comprehensive security training, to find the hopefully kind of obvious security flaws in this design here? So let's apply the first of the 7 principles, which is comprehensivity. The naive solution, really, it's oversimplified even for just being a naive solution, because there's a lot that I didn't include on that diagram. So let's try and flesh it out a little bit. We're going to be hosting on AWS, so I need to include that in the diagram. And the hotel has their own infrastructure, and so I need to spell out what that looks like. So even at a purely technical level, my original naive solution, it omitted quite a lot. So I need to start applying the principle of comprehensivity. I need to think a little bit more deeply about how am I going to be hosting the application, and what does the entire infrastructure look like in the real world. Sticking with the principle of comprehensivity, let's talk with a domain expert. I was chatting with some of the people, the business folks at the hotel, and they said in their experience, you might presume that the big risk here is that the bad guys would want to steal credit card numbers. Turns out that's not the case. The bad guys already have stolen credit card numbers. Their experience in the real world was that the incidence of fraud on their site that they'd seen over the years was not people trying to break into their site and steal credit card numbers. It was people using their site to validate lists of stolen credit card numbers that they had by making small charges. And that was a bigger concern for them than actual theft of stored credit card numbers. So we're going to add that to the diagram. The domain expert also points out that there are actors missing from the threat model. It's not exactly clear how they fit in just yet, but again, I'm aiming for comprehensivity. I want to include everybody. So I'm going to include that on the diagram while I'm getting started. It's important to remember that the comprehensivity principle requires not just identifying actors and risks, but also accounting for them. So I've been showing you some diagrams on the screen. You might be wondering how I built this. I used a tool called the Microsoft Threat Modeling Tool 2016. This is a free tool from Microsoft. It's the best thing I've seen in terms of automation for building a threat model. I really recommend that if you are involved in any kind of application design whatsoever, you get this tool and try it out. The only real limitation of the tool that I've found is that it only works on Windows. There is an OWASP project called Threat Dragon that aims to build a cross-platform alternative to that, but it's in its early stages now. So for the time being, the Microsoft Threat Modeling tool is the best thing that I've seen going. So the threat model helps out with deciding how to prioritize the risks that are identified and what you're going to do with them in its analysis view, which is what I'm showing you here on the screen. We're going to return to this analysis view later. I'm not going to account for the threats at this early stage in the application development process because we're not required to do all 7 principles in order, and we're not required to decide on mitigations for the first principle before we move on to the second. One of the things that distinguishes these 7 principles from a checklist is that they all interact with each other in ways that will become clear as we move forward. So in general, you should expect to consider all 7 principles at least twice at the beginning of an application development cycle. But if you look at this list, we see, having just talked a little bit about comprehensivity, we're already off to a pretty good start. Another interesting application of the principle of comprehensivity is training. You should train your development team on security, but the interesting thing is that training is expensive, so you need to decide really carefully how you train. And the most important training you do might not be on things like the OWASP Top 10. It might be on things like understanding your business domain and understanding the assumptions that are built into your threat model. For the opportunity principle, there are 3 factors we need to consider, which is actor relationships, material resources, and strategic opportunities. So for actor relationships, the hotel has existing security infrastructure, and so does AWS. The hotel also has a business partnership with a credit card tokenization service. We're also going to consider information sharing with others in the same line of business. There are organizations for specific industries that allow the members to share information about threats that they've uncovered in their business domain. For material resources, we need to follow the AWS Security Best Practices white paper, and we also want to use managed services instead of maintaining bare metal. This is the area where checklists like the OWASP Top 10 actually make sense. And then for strategic opportunities, we want to, pardon me, I skipped ahead a little bit. We want to work with business users to design a process that doesn't require creating user accounts and passwords. There's obviously a lot more that we could do. I'm limited in the number of ideas for opportunity that I can present in a single talk. I'd be happy to talk in person with you a little bit more about this. So I want to, for the principle of rigor, I'm going to depart from the threat model for a second, because in applying these 7 principles, our goal is not just to build out a threat model, but really to build a secure application. And the threat model is in support of building the secure application design. So there are 2 steps to the principle of rigor, which is specification and enforcement. And you can specify a system with varying degrees of formality. So a sequence diagram, like you see on the screen, is a little bit more of a formal specification than a plain English description, and a little bit less formal than a modeling language like TLA+. If you need strict formality, you can use a modeling language and a model checker, but even specifying your system with a simple sequence diagram can really clarify how the design should be implemented. The last part of the rigor principle is enforcement of the spec. So one good way to enforce the specification you come up with here is in the type system of the language you're using. If you make it impossible to construct incorrect state, then the compiler will look out for you and see that you are in fact following the specification you've created. Another way to enforce the principle of rigor, which is practically free, is static analysis. So let's talk about continuous integration. We don't often think of continuous integration as a security tool, but it's super, super, super effective. It's more important to have a practice of security checks in continuous integration than any specific list of checks. But just to give you an idea, one example of this is the OWASP dependency checker. You may today not be depending on any vulnerable components, but without changing anything, you could do a new build tomorrow, and there might be a new vulnerability discovered in some component that you've transitively included, 3 levels down from the things you actually depend on. So a tool like OWASP Dependency Checker running in your CI system will find these things as time goes forward. So let's step back a sec and look where we're at. We started with this naive solution on the top, and now we're at this rather more comprehensive and bigger diagram on the bottom. And so, okay, awesome. Like, look at all the security features that we've added to our process here. Like, this is a good thing, right? Maybe. The principle of minimization, the next one we'll consider, applies in many ways to our project. And this is what I mean that these 7 principles are not just items to check. They're ideas that work sometimes in opposition to each other. But with the principle of minimization, we want to minimize the attack surface by putting servers behind firewalls. We want to block SSH into the private network, except maybe via a jump server from known IPs. But also, it's an end-user consideration. We want to remove user interfaces that aren't used commonly and maybe don't get quite the QA and the security analysis that more commonly used user interfaces do. AWS actually makes minimization kind of hard. It feels like a Lego set, and you can just keep throwing more bricks on the pile. We want to delete code that's not used. We want to minimize the data we store. You don't want to make yourself a target. So this is not just a good idea to minimize data you store. It might actually be a compliance requirement. The default of most databases is to store data forever, except for MongoDB. But from a security point of view, it might not be a good idea to have 10-year-old transactions for your end users in your production database. It might not be something you need on a day-to-day basis, and it's just, the best way to keep your end users' data from being stolen is to not have it. So if you can remove old data or move it into cold storage, you're taking an opportunity away from the attacker to steal data that maybe you don't even need to be tracking in your production system at all. The next principle is compartmentalization. There are 3 steps to the principle of compartmentalization. The first is to totally isolate each element on the system to enable specific interactions needed, and then to control these enabled interactions. A great place to start is any place on the diagram where data flows cross boundaries. So in a traditional, like a naive solution like I showed you in the beginning, we might take a Windows server, install IIS, install SQL Server, connect those things together. It might make more sense to have these IIS and SQL Server on separate machines or separate VMs and to use a firewall to restrict traffic between them. It removes many opportunities for lateral movement between the web server and the database server. Another example, and this is, I alluded to this earlier, there's a misconception about compartmentalization, and it's this notion that we have a demilitarized zone where the entire public internet is trying to break into us, and then we have our safe internal network. And that just falls apart in the presence of phishing. The best way to get into someone's network is to call an employee and ask them for their password. So instead of thinking about compartmentalization as being a safe side and an unsafe side, we want to use the Google BeyondCorp model and to say we're unsafe everywhere, but we want to use identity to reduce the ability to move from one side of a partition to another. And another misconception is that compartmentalization is only about network perimeters. So here's an example of compartmentalization that's got nothing to do with network perimeters, which is compartmentalization of privilege. We want to work in an identity that has the least access needed in order to get our job done. And this may at first seem like a conflict with the principle of a human-centered design. I mean, everybody's been annoyed when we're not allowed to do things that we need to do in order to get our work done. But I'll tell you, as a human being, I want devices and systems that are designed to protect me, not explode if I press the wrong button at the wrong time. So here's some decisions that we might make. And again, there are many more decisions that we might arrive at if we drill down deeply enough. So for the principle of fault tolerance, we need to consider fault tolerance for every point in the system. I'm going to give one example of fault tolerance. So let me talk about fault tolerance for just a moment. I saw an interesting technical paper written a few years back that noted that in cases where software systems failed disastrously, like didn't just have an error, but the error brought down the entire system, it wasn't typically a bug that brought down the system. Rather, what happened is there was a bug and then the error handling code, which got a lot less attention in security and QA than the rest of the system did, failed disastrously. I mean, just to give one example, logging is something that I think developers sometimes think of like air. It's just, it exists, we can use it, it's no big deal. But I have seen more production systems brought down by logging systems that when something starts to go wrong, they log more and more errors, and those errors cause more errors, and eventually it chokes out the entire system. So it's important to test not just the happy paths, but also the failure paths for every point in the system. And it's not just a technical concern. So an example of a non-technical failure is compromised credentials. So what does it mean to test to test compromised credentials? Well, I think because we can identify from our threat model that compromised credentials, and this means like the API keys that we use are stolen or end user credentials are stolen. I mean, you all probably got the update from Twitter this week. We need to think, what would our response be, and not just make up an incident response strategy after the bad thing has happened. So a typical response to comprehensive credentials from a typical vendor, and certainly this is true of my bank and my credit card company, is, your credentials were stolen from us, here's some free credit monitoring. And I just don't find this a good response because it doesn't really address the concern of user safety. We need to think, how do we protect our end users in this scenario? We need to stop the exfiltration, assess the scope of the damage, make sure we're limiting further damage to the end users, and then go talk with the end users and understand their concerns, listen to them. Okay, once I understand my end users' concerns, I need professionals to help me design a strategy to make sure it doesn't happen again, and how can I mitigate any of the real concerns that my end users have. Having gotten this far, we now have a really extensive list of risks. So now we're going to apply the principle of proportionality. We need to make sure, and this list could be hundreds or thousands of lines long, so we need to say, how can we triage this list of risks and make sure that we're addressing the most important things first? So the Microsoft Threat Modeling tool has some features to help with this. The highest priority issues are those which directly or indirectly affect human safety. The point of security is not just to exist solely for the sake of security. Security should always be in furtherance of some greater organizational goals and needs to be crafted with those goals in mind. So for each item in the list of threats, we need to consider the priority and the status. Have we not looked at this issue yet? Have we decided that this issue is important and it needs investigation? Should we decide it's not applicable for some reason, and we can record the decision we made and why we believe it's not applicable to us? Can we mitigate the concern or fix it? Or another option we have is to accept the concern, and that typically means going to the business and saying, we're aware that this is an issue. Is this something that you're just willing to accept as is, or do you want to spend money to mitigate it? Because these basic principles interact, we can't just go through them once and have a finished application design. The bare minimum at the start of an application development lifecycle is twice, but you should plan on more. And especially if you're using an agile design process where every couple weeks maybe you're grooming your backlog, thinking what have we learned from end user demonstrations and from end user interaction with the product we're building. We need to revisit the design, and that means probably going through all 7 principles at least once when you're planning each sprint. And actually, I think this works really well because often as the design of a software system evolves, and especially as we start working with real end users and seeing them interact with the system, we learn what are the security barriers that we have in place, and is it usable by a real-world end user, or is this something that the end users are trying to work around? If an agile process encourages you to keep drawing water from that well I think it's a really good fit for a secure design. So if you'd like to learn more about the ideas I've presented here, the first place I would start is the Information Security Practice Principles. There's an O'Reilly ebook that's available, or there's a very similar white paper that you can download from Indiana University. This is a pretty short document. It's 50, 70 pages or so, and it's a very high-value read. You can probably read through it in an evening, and it will really, I think, up your ability to integrate security into the process that you already have. If you take nothing else from this talk, I would really encourage you to go through and read this white paper. If you want to learn more about threat modeling in general, unfortunately, I don't have quite as good of an answer. There is a book called Threat Modeling, Designing for Security by Adam Shostak. It's a pretty good book, but my recommendation here is a little tepid. It's really the only good resource that I know about, but it's like 700 pages long. It's a big old book, and it's pretty old, which is not a problem by itself, because the notion of threat modeling is kind of timeless. But unfortunately, the book references some tools that are just not available anymore. So you kind of have to read around those sections, which means you're skipping around a lot. So a big book that you have to skip around a lot, my recommendation is just a little bit hesitant, but it is the best thing that I know of out there. There are also some recordings of some threat modeling talks from some of the security conferences that aren't too bad if you're okay with a video online format. I want to give some credit to the stock photography I used during the presentation. And also, if you'd like to talk with me in person, I love sitting down for lunch. We can do it here at the conference, or be happy to buy you coffee someday. Encourage you to reach out, and I'm really interested. I feel like this is a new field, and I have experience talking about how to integrate security into an application development lifecycle with a number of different organizations, but every organization's a little bit different. And every time we talk through this, we find new challenges and new opportunities for integrating these ideas into the real processes that real companies use. So I would very much appreciate the opportunity to buy you coffee, or if you're not a coffee drinker, buy you a nice smoothie, and talk through what this looks like at your organization and what the opportunities look like for making your process better. I'd like to thank you for coming to my talk today. I hope you enjoy the rest of the conference. Please do feel free to reach out to me on Twitter or via the DM in the Slack channel. We have any questions from Slack? Okay.
The question, in addition to identifying an application's threat...
Just talk in here.
In addition to identifying an application's threat model and domain risks, shouldn't you build to comply with regulations that one could be audited for?
Absolutely. You should build to comply with regulations. I'm guessing that this question came in before the slide ahead where I talked about the GDPR and other regulations. So I'm working in the utility space right now, and the Ohio PUCO has regulations. You know, when we display a customer's data, it's required to be in the same format as the bill. So yes, this is a great example of one of those non-technical, domain-specific requirements for a particular project that you won't find out about unless you're on really first-name terms with the business user. So absolutely, that's important. Why don't you come in here in the white box so they can see you? Okay, thanks a lot. Any other questions before I let you go? Okay, thanks very much for coming out, folks. Enjoy the rest of the conference.